The base 10 represents 2 times 11. Okay, because we have 10 and 1, 10 and 1. Use base 10 to work out 3 times 11. Draw your base 10 and complete the multiplication. So you need to do 3 of these. Yeah, you need to do your long things with 10 cubes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Oh God, have I got to do this 3 times? Okay, and then again like this. Yeah. So I don't think I need to draw it all out. I think you understand that, right? You need to do 3 of these. It takes a while, so I don't want to draw it all. Okay. What would 3 times 11 equal? 33, right? There we go. So that would go in there. Okay. Now, quick fire round. Complete the calculations. 5 times 11. Quickly. 55. 9 times 11. 99. 6 times 11. 10 times 11. Good. 7 times 11. 4 times 11. 3 times 11. 33. And 12 times 11. Good. You remembered from last time, yeah. Okay. Rosie is spotting patterns in the 11 times table. When I add together the digits of each multiple of 11, I always get an even number. Okay, 2 times 11, 22. 2 plus 2 equals 4, which is an even number. Do you agree with Rosie? So let's see. So if you go through the 11 times table, you start with 11, and then Rosie's saying if you do 1 plus 1, which is from the 1s and the 10s in the 11, you get 2, which is an even number, and so on. She's done 22 here for you, and then 33 would be 3 plus 3, which equals 6, and 44, 4 plus 4 would be 8. Now, shall we try a really high one, like, what about 12 times 11? What does that give us? 12. Well, what is the answer first? What is the answer? 12 times 11? 132. So, yes, she's saying digits. So if you add them individually, because I wasn't sure she meant 13 plus 2, but I think this is the correct way. So then you get 6, which is an even number. Yeah, so it seems to work. So I guess we'll say yes so far. I mean, we haven't tried out every single one, but I think you've tried out most of them. Okay, and then explain your answer. Well, you can say that after testing out using different multiples of the 11 times table, you always got an even number. Shall we try, what about, shall we try 10 times 11? No, that would also be, yeah, because, yeah, that's because you'd add a 0, and that would also be 13. So what is, we're running out of space now. Maybe I'll write it here. What is 13 times 11? So this is 12 times 11. What is 13 times 11? Yeah. Okay. Yeah, so, yeah. Yeah, so it does work. So it seems to work all the way up to the 13, 11 times 13. Okay. 9 times 20, we're doing the 11 times table. 11 times 20, well, it would be double this. What's 11? It would be double this one. I can already tell that it would be an even number. It's double this, so it's 220. So it's 2 plus 0, which equals 4. Yeah. All the ones we tested, so, and we just randomly picked a load, so I think it probably does work with all the numbers. We can guess from that. What else do you notice? What other patterns can you see in the 11 times table? Well, what patterns do you see in the 11 times table in general? The one pattern that is clear, that is obvious, is you just use the digit that you times with 11 and put it in the 10s and the 1s. Okay? If you do 1 plus 1 is 2, and then the next one is 2 plus 2 is 4. So it's sort of going up in 2s. Oops, what am I doing? Yeah. So they appears to go up in even numbers, right? When you add the separate digits. Okay. Right. So let's move on. Number 4, crayons come in packs of 12. So we're doing the 12 times table this time. Dora buys 5 packs of crayons. How many crayons does she have? So it is basically 5 times 12. Yes. Yeah. Which equals 60. Okay. Ron uses a bar model to represent 84 divided by 12. Oof. So let's see how many times 12 goes into 84. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Huh? Right, yes. That's very odd. So explain Ron's mistake. Oh, right. No, his mistake is you should have put them, because you said 6 times, you said, hang on. So what is 84 divided by 12? Okay. Are you sure? 84. Okay, let's do the 12 times table. 12, what's next? Wait, it's not 48, is it? 12, 24, 36, thank you. Fifth, no. 48 plus 12. 60. Okay. So 1, 2, 3, 4, 5, 6, 7. 7. So it goes 7 times. So his mistake, he's got 12 groups here. These should all be 7, shouldn't they? Because there's 12 boxes here. So they all need to have 7 in them. Yeah? B, draw the correct bar model diagram to represent 84 divided by 12. So I just showed you. You can either do it this way, or you can split the 12s into 7 groups. Yeah? Or you can do it the other way around, which means you have... Yeah, this is why I didn't want to draw it, but okay. 84, and then you split it 7 ways. 1, 2, 3, 4, 5, 6, 7, and you put 12 in each. Yeah? Does that make sense? He makes 12 pictures like this one. How many shapes does he use altogether? So we need to count the number of shapes in this box and times it by 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. In other words, it's 12 times 12. 12 times 12. What does that give us? 144, right? If you're not sure, you can do 10 times 12 equals what? 10 times 12? 120. And then you can add 2 times 12, because obviously this makes 12. So 2 times 12, what does that give you? 24. And then if you add them, you get your 441. Okay, 144. Okay, now, if each picture is exactly the same, how many of each shape does Emil use? So if you look here in the box, there's 2 squares. So in other words, that's 2 times 12. Good. And there's 5 circles, so that's 5 times 12, which is 60. There are 2 stars, which are the same as this one. And then there are 3 triangles, which makes 36. Okay, so Mr. Scott is organising a cricket tournament. There are 11 players, 11, in a cricket team. 5 teams have signed up for the tournament. How many players have signed up? So 11 times 5, 55, right? Okay, now this is the one we did before. Mr. Scott needs 132 players signed up to go ahead with the tournament. How many more teams are needed? So there's different ways of doing this. He needs 132 players, but he's only got 55. Go through it step by step. So there are 132 players that he needs, but he's got 55, yeah? So how many more does he need? Well, first of all, I'll just show you a different way than before. 132 minus 5. Oh, maybe I should do it over here. Hang on. Sorry. Here. 132, take away 55. Right, well, you can't do this because you need a 1. You need to take one of the 10. So 12, take away 5. Yeah? And then you can't do 2 minus 5, so you need to use this one. Right, so there's 77 players that are needed, that are still needed. And then we need to do 77 divided by 11 equals is 7. So one needs 7 more teams, okay? Dexter has been looking at the 12 times table. He noticed something when he adds the digits of multiples of 12 together. Okay, this is what we looked at before a bit, didn't we? Dexter thinks the next number in the pattern will be 15. Well, 48, so that the 12 times table is 12. 24, 36, 48. What's next in the 12 times table? 60. So then we need to do 6 plus 0, and that gives us 6. Yeah, and that doesn't work. Yeah, it's not 15, is it? It's not 50. So your answer is no. Okay? He is adding the digits from the 12 times table. And your answer here, when you explain your answer, is simply, well, 5 times 12 equals 60, but, noisy. Okay, right, yeah, so 6. There we go. What happens when he tries this for all the multiples of 12 up to 12 times table? That's what we were working out here. Yeah, I needed some space. So, yeah, all right then, let's do it again. So we've got up to 5 times 6. So what comes after 60 in the 12 times table? 72, good. Let's keep going up and then we can separate the digits. What's the next one up? 84. Next one. And one. And then the last one is 144, isn't it? Yeah, 12 times 12. I'll put that here because there's not enough room. Okay, so we need to do 7 plus 7. What does that give us? Oh, what am I talking about? Not 7 plus 7. 7 plus 2. I don't know, I had 7 on my brain. 7 plus 2, isn't it? 72, yeah. 9. 8 plus 4. No, 8 plus 4 is 12. And then 9 plus 6 equals, okay, we're doing the, I'm not sure here where we do 1 plus 0 plus 8, or whether we do 10 plus 8. If we do 10 plus 8, it fits the pattern, you know? Adds the digits, yeah. So the thing is, if we were to do 10 plus 8, it would be 18. But now, if we add the individual digits, it doesn't work. So there is a way of doing this pattern, but yeah. So in other words, this is 9. So again, we're back to 9. Let's see, what's the next one? It's 1 plus 2 plus 0, 3. Okay. And then it's 1 plus 3 plus 2, which gives us 6. So it's going back down. Oh, okay, and then 144. This pattern is strange. They're all multiples of 3, but okay. So this one equals 9 again. Okay. So one thing we can say is they are all multiples of 9, but there doesn't seem to be a pattern. Yeah, exactly. It's just random. Because look, we've got 3, 6, 9, 12, 6, 9, 12, 15, 9, 3, 6, 9. I can't see any pattern there. If I write them all out, maybe it's... So these are the numbers. So it goes 3, 6, maybe I'll do a comma, 9, 12, 6, 9, 12, 15. Okay, I'll rub this off. So it's 9, 3, and then 6. 9, 9. I suppose every 2 digits there's a 9. And there's a 12 here, but it doesn't carry on here. So I don't think there is a proper pattern. Who knows if there's another 9 here? I don't think there will be necessarily. So we'll say that we couldn't find a pattern, yeah? So you can say the answers are, sorry about my handwriting, the answers are multiples of 3. Multiples of 3, but there is no, oh, I haven't got space now. If I go down, but there is no pattern, but there is, maybe you find one, I don't know. I didn't find one. There is no pattern. Okay, that's what I would write, but maybe you word it differently. Like you said, random, which is fine.